worries. Okay guys, our last video got kind of cut off there abruptly, so we still have complex trinomials to review and then factoring using the quadratic formula. So now when we're looking at complex trinomials, it's still 3 terms, but now the a value is not equal to 1, nor can you make a equal 1 using common factoring. So in that previous simple trinomial example, we could factor out that 3, we could make a 1, and then we could proceed with this 2 numbers add to b, multiply to c. So here, this first example, I've got 3x squared plus 16x plus 5, and I can't factor out a 3 from 16, a 5. Like, there's nothing I can do. A is 3. So I have to use one of my complex trinomial methods, and I'm going to show you 2. So I'm going to show you decomposition again. We already looked at a decomposition example, but we're going to look at another one. And then I'll show you another method, and honestly, I don't have a great name for it. We'll call it the T-chart. So, decomposition. So I need to decompose this middle term into 2 numbers that I think will be factored well with this 5. And there's a few ways we could go about this. It could be 6 and 10. We could try that. It could be 1 and 15. It could be, what else? That's it. Right? Like, we need a multiple of 5. Our options are 5 and 11. No. 6 and 10, 1 and 15. So let's just try 1x plus 15x. Okay, so 1x plus 15x is 16x. So we've got 3x squared plus 1x plus 16x plus 5. And sorry, that should be 15. And I'm specifically choosing this one because I want to show you what happens when we are factoring with this 1x, but we'll get to that. Okay, so now I'm grouping these first 2 terms, and I'm grouping these second 2 terms, and I'm trying to do some factoring by grouping. So what is common between these 2? Well, that's just x. So if I factor out an x, I'm left with 3x plus 1. And what is common between these is positive 5. And if I factor out positive 5 here, I'm left with 3x plus 1. And you'll know that you've done it correctly when what is in the brackets is the same in both terms. So again, I still have only 2 terms. I have this term, and I have this term, and technically the positive 5 belongs with this term. So now I'm factoring again. I'm doing some common factoring. I'm saying, okay, what's common between these 2 terms is 3x plus 1. And if I factor out a 3x plus 1 here, I'm left with an x, or in other words, if I were to redistribute, 3x plus 1 multiplied by x would give me back 3x plus 1 times x. And then 3x plus 1 multiplied by 5 would give me back 5 times 3x plus 1. So there's my 2 factors, and that is using decomposition. And depending, because we are all over the place in this course from different boards, different schools, and if that's the method you use, then that's the method you're going to keep using. Now, another method that you may or may not be familiar with is the T-chart. So again, I've got 3 terms, 1, 2, 3. A is not equal to 1, nor can I make A equal 1. I cannot divide 27 by 4, so right away, and I can't divide 18 by 4, so I'm stuck. And so this method, you're going to create this T-chart, and on one side, you are going to write all the ways that you can multiply 2 numbers to get 4. So you could do, let's just do this, you could do 4 and 1, 1 and 4, 2 and 2. Now notice how 4 times 1 and 1 times 4 are the same, only for one of the numbers. We're going to do the same thing on the other side of this T-chart. We're going to write all the multiples of 18. But I don't need to consider both, like 1 times 18, 18 times 1, so on and so forth. I only have to do the flip for one side. So because I've considered all possible combinations for 4, when I jump to the other side, I can do 1, 18, I can do 2, 9, I can do 3, 6. I can't multiply 4 by anything, can't multiply 5 by anything, and by the time I get back to 6, I'm back to this 6 times 3. So I don't have to do the reverse. I don't have to do 18 and 1, 9 and 2, 6 and 3, because I did both options for this. So now we're going to do some cross-multiplying, and this is really tricky for me to show you on the computer, and honestly I haven't figured out the best way to do this. But let's just try it here. So I need to look and say, okay, what if I did 2 times 6, which is 12, and 2 times 3, which is 6. Is there a way that I combine 12 and 6 to get the number 27? Now, I can do 12 minus 6, and that's 6. I could do 12 plus 6, and that's 18. Neither of those are 27, so this is no good. So I need to go on to the next possible combination of numbers. And remember, we're trying to get to this 27. So I did the 2s and the 3 and the 6. So then I might say, okay, well, let's do 1, and we're going to be here a while. Okay, let's just eliminate the 2s. So let's go 2 times 9 is 18, and 2 times 2 is 4. That's going to give me at most 22. That's no good. So now I just have to check 2 times 18 is 36, and 2 times 1 is 2. Again, even if I subtract, 36 minus 2 is not 27, so that's no good. So what I've done now is I've got rid of the possibility that these 2's have anything to do with the factoring here. So I'm going to go, those are not part of it. So now I'm going to go back over here and say, okay, well, what if I do 1 times 6 is 6, and 4 times 3 is 12. And again, I already had those numbers. 6 and 12 cannot be combined to give me 27, so that doesn't work. So I'll say, okay, what if I do 1 times 9 is 9, and 4 times 2 is 8. 9 and 8 cannot be combined to give me 27, so that's no good. And then I can say, what if I do 1 times 18 is 18, and 4 times 1 is 4. Again, the most that's going to give me is 22. That's no good. And I know it seems like it's taking a long time, and eventually you'll figure out the patterns, and you won't maybe have to go through them all, but just for showing you. So you're like, okay, that doesn't work. So then we go back over here and we say, okay, well, let's do this one then. 4 times 6 is 24, and 1 times 3 is 3. Well, 24 and 3 can be combined in some way to give me 27. So, good news is I have found my numbers, and the ones on the top stay together, and the ones on the bottom also stay together. And so my factors are, this is going to be my x term, is going to be 4x and a 3. And over here I'm going to have 1x, or just x, and a 6. And then I have to figure out the sign that I need to be in the middle. I need to have a positive 24, and I need to have a positive 3. The numbers that are going to give me 24 of these x's here are this 4x and this 6. The 4x is already positive. So to make sure that that 24x stays positive, this 6 has to be positive. And the numbers that are going to give me the other 3 x's are this 3 and this 1x. The 1x is already positive, so to make sure that the 3x stays positive, this 3 would have to be positive. So my factors would be 4x plus 3 multiplied by 1x plus 6, or we could just write it as x plus 6, with still obviously the 4x plus 3. Okay, so it depends where you are coming from. You can choose either of those methods or another method if you have one, but that is factoring complex trinomials. It will absolutely be expected that you just know how to do that. And then last but not least, we have when we can't, when none of these methods work. And I say when none of these methods work, but you should also know that the quadratic formula can be used for all quadratics, even if one of these methods work. The thing is in theory, the quadratic formula should be what takes the longest. And if you are really good at factoring, using difference of squares, perfect square, simple trinomial, even complex trinomials should be faster than using the quadratic formula. So you can use it for all quadratics, especially if you're checking your work, but you will be expected, or sometimes you'll say, without using the quadratic formula, factor the following, for example. Okay, so for example, here, we want to factor this quadratic. It's a simple trinomial in the sense that a is 1, but can I find two numbers that add to -3 and multiply to 7? Well, the only numbers that multiply to 7 are 7 and 1, right? 7 times 1. There's no way I can combine a 7 and a 1 to get a 3. I could get a 6, I could get an 8, I cannot get a 3. So I cannot use my simple trinomial methods. So the next thing I want to do is, this is our quadratic formula. I'm sure you guys have it memorized. -b plus or minus under the square root b squared minus 4ac all divided by 2a. Now, this plus or minus is where we get our two different roots from. We do all of this, but we do it with a plus, -b plus all of this, and then we do -b minus all of this. Now, under the square root is called your discriminant, okay? So b squared minus 4ac is your discriminant. And if you put any number in here that is greater than 0, okay, so if that is greater than 0, the square root of some number, whether it's, let's just call it 9, let's just say, if we take some number and we add 9 to, or add 3, sorry, we take the square root, if we add 3, or we take that same number and we subtract 3, we're going to get two different answers. There's no number where you can add 3 and subtract 3 and get the same number. So if the discriminant is greater than 0, then I will be adding that number to something and subtracting that same number from something, and therefore I will get two different solutions, or two different intercepts, what we can call them, our solutions. If b squared minus 4ac, so the part under the square root, works out that it is exactly equal to 0, okay? So if we put something in here, if this was b squared was 4, so we have 4 squared, and we multiplied if a was 1 and c was also 4. Those are not, I don't know what happened there, but that's 16 minus 4 times 1 times 4, which is also 16. 16 minus 16 is 0. If that happens, the square root of 0 is just 0. Whether you add 0 to a number or subtract 0 to a number, you will just have that number, which means you will not have two different solutions. You will have, therefore, one solution. And if the discriminant, b squared minus 4ac, is less than 0, so that often happens when you have a really large a value. It could be c. But if what's under the square root works out that it is less than 0, we can't take the square root of a negative number, so it's not possible. We have no solutions, all right? So just, you can save yourself some work if you check the discriminant first. No solution. So if we're looking at this example over here, we have an a value that is 1, but it's not factorable. We already checked that. We have a b value that's -3, and we have a c value that's +7. And we want to just quickly check our discriminant, because if there's no solutions, then we're not going to mess around going through the whole quadratic formula. So we have b squared minus 4ac, -3 squared minus 4 times 1 times 7. So -3 squared is 3 times 3, which is 9, minus 4 times 1 is 4, times 7 is 28. 9 minus 28 is going to give us a negative number. So this example here has no solutions. We are not going to go ahead and use the quadratic formula. It's not factorable. It has no intercepts. You guys already know how to use the quadratic formula, but I just wanted to remind you of the discriminant and how you can use it to check before you proceed. But beyond that, you would just sub in the values and have your two different solutions. So this last page, I would recommend you pause the video right now, and even if you're just looking at these, just by looking at them, because to be efficient at factoring is to know what type of factoring to use and when. And so right now I want you to just look at these and be able to point and say, yep, I would use that form, yep, I would use that form, because we've got a whole list of different types of factoring here you can choose from, and you don't want to be scrambling like, I don't know, which one am I supposed to be using? Okay, so pause the video right now, see if you can determine what would be the most effective form of factoring for that question, all right? Okay, so if you paused and you've come back, here we have three terms. The first is a perfect square. The third is a perfect square. The square root of the first is 5x. The square root of the third is 4. 4 times 5x is 20x times 2 is 40x. This is a perfect square trinomial. Okay, so I'm not even going to put the answers just for sake of time, but we have a perfect square trinomial. So you would be using that method. Okay, this is a trick, not a trick, but this is tempting to use the difference of squares. This is a perfect square. This is a perfect square. This is not a difference. This is a sum. And so we can't use difference of squares. We can't use common factoring. There's nothing common between the two of these. This is not a trinomial at all, so we can't use simple trinomial methods, complex trinomial methods. This is a quadratic that is not factorable. And if you think about what we're doing when we factor, is we're finding the intercepts. And if you can refer back, or if you think back to transformations, what is the transformation being applied to this polynomial? It just has a vertical translation up 25. So all we've done is taken the parent quadratic, which is like that, but right at the origin, and shifted it way up 25, and now it's up here. So it's not factorable because there's no solutions. Okay, here we have a simple trinomial. A is 1, and we can't just conclude, but first we would have to check, is there two numbers that can add to this, multiply to this? So we have a simple trinomial here. Here we have what appears to be a complex trinomial, but first off, this is degree 7, so this is not a quadratic at all. Our terms are not in descending order, and these are all multiples of 5. So we would need to do some common factoring, and the most we could factor out here would be a degree 2, leaving this as a degree 5, and we have no methods yet for factoring a degree 5, so all we could do here is common factor, and then we're done. This one over here is a complex trinomial. A is not equal to 1. We can't make A equal 1. We would proceed with some of our complex trinomial methods, either decomposition or that t-chart, or you may proceed to the quadratic formula. You're going to have some really big numbers, but if you are overwhelmed by the big numbers that are already here. So this is either complex trinomial, it could be quadratic formula, and if you were going to use quadratic formula, you would double check that that discriminant is in fact greater than or equal to 0. And then here we have perfect square, subtraction, so we have a difference of squares. Okay, so that is a quick whirlwind review. You would have spent probably an entire unit covering these topics in 3U and 2D, and now I've just done it in one lesson. So to take what you need, practice what you need, but do make sure that you are fully confident in your factoring methods that you already know from grade 10 and grade 11 before you move on.